Hello and welcome to this video. Starting from this video, we will learn about classes and object-oriented programming in Python. So you might be aware of classes or object-oriented programming in C++ or Java. Object-oriented programming in Python is simpler compared to those languages because it does not have virtual functions or it does not have access modifiers like public, private, or protected. So there are three aspects of Python which are very powerful. First is inheritance, in which you derive from a base class to create a subclass. Base classes are also known as parent classes, and subclasses are also known as child classes. The second aspect is composition, where you take several classes and you compose them together to build one class. Also, it is known as multiple inheritance in a way. And third is polymorphism, in which a class behave depending on the state of the object. So we have already dealt with several uh, pieces of code in Python. So the distinction of class is that it can have multiple instances, that is multiple objects. You customize it via inheritance and you have operator overloading in a class. So for example, I have a class, my simple class, in which there is a class level attribute I initialized with value 10, and I have function f which returns hello world. So you can create x is equal to my class parenthesis. It will create an object x, and then you have x dot I and x dot f. Now suppose I say x dot I is equal to 20, and let's say I say y is equal to my simple class. So the I of x is different from I of y, because you see, even though you have assigned I a value of 20, the I of y is still at value 10. So even though it's a class level attribute, if you change it via object, the object gets a copy or namespace of its own. So let's see how it looks like. Python class 1.py. So first it prints x.i, then it invokes function f on x, and then it prints y.i. So y.i did not get changed because we assigned to copy of x.i. But if we assign it to my simple class.i and we see here x.i, then you will see, and y.i also, then you will see that both have become 20 because you are now changing it through the class attribute rather than an object interface. So both became 20. Now this function f, you see this particular self parameter, this is the object on which you are operating upon. Now let's change it a bit. Say it takes a parameter called name. So I give my name here, and let's remove these three lines, and we change this, return self dot name. Okay, so now it will print 10 and Shiv, because x is now initialized with a name Shiv, not here. Here. So now it is not self dot name. Sorry, only name. So now it will print Shiv here. There you go. But you can have object level attributes also. For example, you can say self dot name is equal to name. So this is now an object level attribute, self dot name. Let's return that also. So in this case, or even better, if you want to set up a class with certain state, then you can have underscore underscore init underscore underscore function, which is more like a constructor of a class where you set up the initial state of the class. So in this case, we pass here in the constructor and we call f. Let's say f returns here def f self. Okay, this should work. So now it should print Shiv from function f. So this is now an object level attribute because you can't access name at a class level. For example, if you see my class my simple class dot name is equal to, let's say, s. Then it won't work. It will give an error because class does not know about the name, but it will definitely print shiv here. So it prints shiv, but what happens here is it's not an error, but it will create a new class level attribute. So now you can print x dot name like this also. To avoid the confusion, we call it g. Let's see. So there you go. So when you assign to an attribute over the class, it will become part of all other objects which are there in existence. So much for the simple classes. Now let's deal a bit with uh, inheritance. So consider we have a class person which takes two arguments for the constructor, name and age, and then these are assigned to the object level attribute, and rep and str functions are the Unicode and string representations, and f is hello from person. So if you create it like this, it print will invoke underscore underscore str underscore underscore. And now we also have an employee person. In this case, it also takes extra argument called position. It calls super. Note that person is in parenthesis. That means it's a child class of person. So it calls the constructor of person class, and name and age are passed to that. So name and age gets assigned in person class, and position is part of employee. So if you run this, let's see how it looks like. Oops, I'm not saved. Okay. So first, it creates the object X there, person with Shiv and 20, and then it invokes the string operation. Then you have the string representation of the employee class, and then you invoke the F function of parent class through the child class. So this is how you deal with inheritance in Python. Note that name and age in employee are being set in person class, and also you can invoke any method which is there in the parent class through object of the child class. But if you overwrite this, you can always overwrite this attribute here and say, let's say hello from employee. Then it will call the overridden function hello from employee. So note that if you want to override, you can override, or if you don't want to override, you don't override. It depends on the design of your class, how your inheritance will work. So in the next class, we will look at two different things. Those are class methods and static methods of a class. After that, we will look at operator overloading, followed by decorators and meta classes. If you have found this video informative and useful, please like the video and subscribe to the channel so that you get updates from the channel when new videos are posted. Thanks a lot for watching the video. Happy programming.